guys, we will talk about the laws of exponent. Exponents, they are usually used in significant figures, in numbers, and in measurements. And we're going to talk about the product rule, and quotient rule, and so on and so forth. And it's extremely important to engineering students and high school students. So let's move on and start. So product rule. The concept of product rule is that when you're multiplying two expressions with the same base, let's say a and a, like multiplication, that's multiplying, you add the exponents. So that would be a plus 1 plus 1. That would be a2. It would be a squared. And another example would be b times b cubed. So that would be b 1 plus 3, because the value of the exponent of b is 1. So I can say this is b to the power of 4. And moving on, I will provide at least 5 examples. So first example, let me erase it first. First example is x cubed plus x times x fourth, times x fourth. As I've said earlier, when you're doing product rule in exponents and the laws of exponents, you just add the exponents. So that would be x cubed plus x to the power 4. That would be x to the power 7. And if you expand that, that would be x times x times x times x times x times x times x. And that's how you do it. So that would be x is equal to the power of 7. Moving on to another example. So moving on to another example, 2 to the power 5 times 2 squared. So same rule, you just add these two, addition. So that would be 2 to the power 7. And if you expand that, 2 to the power 7 is equal to 128. Or if you want me to expand it, that would be 2 times 2 times 2 times 2. And if you get the value of that, the product of all of these would be 128. And that's how you answer product rules in the laws of exponent. Next would be another example, y to the power 7 times y. If you expand this, that would be y7 plus the power of y. You just add these two, and that would be y to the power of 8. And another example would be 3a squared times 4 to the power 5. If you observe, we have the same base, but we have different coefficients. But nevertheless, the important thing here is we have the same variable or the same base, and the difference is that we have a difference in number. We have different numbers in exponent or different values in exponent, but still that doesn't matter. You can still combine this, or you can still get a product of this. And if you multiply these two, first you would get 12, because 3 times 4 is equal to 12, and a squared times a to the power 5 is equal to a seventh. You would get 12 to the power of a7. Yeah, that's all you need to do. So next example would be negative 2x cubed times negative 5 x to the power 4. As we can see, we have the same variable, we have the same base, but we have different coefficients. If you multiply negative 2 and negative 5, you would get positive 10, right? And if you would multiply x to the power of 3 by x to the power of 4, we would get x to the power 7. And the final outcome would be 10x to the power 7. That's your final answer. And moving on, we'll go to the quotient rule. In the quotient rule, you just subtract exponents when dividing identical bases. For example, if you're given b cubed divided by b, you would get b squared because you just subtracted the value of b cubed and the value of b. You just subtract them both and you get the exponent 2 or squared. So I will provide at least 5 examples to each rule. And quotient rule, when you're doing quotient rule, the important thing is you just subtract exponent. That's all you need to do here. So in the first example, you're given x to the power of 8 divided by x cubed, sorry. And remember earlier, you just divide the exponents. Not divide, but subtract the exponents. And that would be 8 minus 3 is equal to 5. So the value would be x to the power of 5. That's how you get the answer. And next would be simplify y fifth over y2. If you see this, this is simply y fifth divided by y2. And what you need to do is just 5 minus 2. You just subtract the exponents. And that would be y to the power of 3. That's how you get the answer. And last 3 examples. 5 to the power of 6 divided by 5 to the power of 4. Since we have the same base, we can just subtract the exponent by each other. So that would be 6 minus 4, you would get 2. So the value would be 5 squared. Or if we expand that, 5 times 5 is equal to 25. Because 5 squared is equal to that. That's all you need to do there. It's very simple. Another would be 12a to the power of 7 divided by 3a squared. If you observe, 12 is divisible by 3. And if you divide 12 by 3, you would get 4. And here, you're given that a to the power of 7 divided by a squared. You would get a to the power of 5. So the value would be 4a to the power of 5. That's your final answer. Wait, last example would be something with negatives. Negative 8 to the x to the power of 4 divided by 2x. As you can see here, negative 8 can be divided by 2. It can be divided. So the outcome would be negative 4. And x to the power of 4 can be subtracted by or divided by x. So we would get x cubed. So the final outcome would be negative 4x cubed. And let's move on to the power of a power. So the power of a power rule, if you remember power rule earlier, the power rule is more on addition. And the power of a power rule is more on multiplication. And let me show it to you. So since you're given the same base, or not the same base, since you're given an exponent outside, you just multiply m and n, and you would get mn, the value of the both, or the product. Let's say you're given 16 squared, and 16 squared, and there's another exponent. You just basically multiply the exponent. So that would be 2 times 2 is equal to 4. And you would get 16 over 4. And that would value, let me check, 65,536. That's the value. That's how you get the power of a power rule. It's pretty simple and pretty basic. Now we're given x squared and an outer exponent of 3. And I would write another example, y to the power of 4 and another exponent of 5 and 2 cubed and an outer exponent of 2. What would be the outcome? So here you just multiply it. So you would get x to the power of 6, because that would be x 2 times 3 and that would be 6. And next y 20, because y to the power of 20, because y is 4 times 5. That would be 20. You multiply the exponents. That's how simple it is. And here we're given 2 cubed and an outer exponent, another outer exponent of 2. And that would be 6, because 2 cubed times 2, or an exponent 2, that would give us 6. And that's how you get 2 to the power of 6. Moving on, in here we have another example, but there's multiple exponents. So what are you going to do? Simply, you just apply the rule. So first we have a squared times 3, and that would give us a to the power of 6. And we have another exponent 4. And you just simply multiply 6 times 4, and that would give us 24. And that would give us a to the power of 24. Pretty big number, but yeah. And here we're given negative 2 x to the power of negative 2 and an exponent of 3. So that would give us negative 6 automatically. That's how you get the answer in power rule, because you multiply negative 2 and 3 and it would give us negative 6. That's how simple it is. And moving on, we're going to the power of a quotient. I mean power of a product rule. Let's move on. When you think of a power of a product, it's more on distribution. So let's say I'm given here 2x to the power of 4. So of course, you're going to distribute it to each one of them. So that would be 16. Yes, 16 to the power of x4. Just distribute it to each one of them. So basically, there's an exponent in 2 and there's an exponent in 4. So that would be 16 x to the power of 4. Simple as that. And I'll provide at least 3 examples on this one. So simplify xy cubed. So basically, you just need to distribute it to each one of them. And that would give us x cubed and y cubed. And if you expand the both of this, that would be x times x times x in a parenthesis of y times y times y. And that would give us x cubed and y cubed. That's how simple it is. And another example, let's say 3x to the power of 4. Let's just say 2. Simple as that. You distribute it to each one of them, and you just that's the answer. Because 3 squared and x squared is equal to 9x squared. That's how easy it is. And another example would be negative 3y squared. So negative 3, if you square it, that would give us negative 3, the squared version of negative 3, or the output of negative 3 squared is 9. And the value of y squared is equal to y squared. So that would give us 9y squared. So that's how you get the answer. And next, x squared y cubed and to the power 4. Here, you just distribute it again. So remember sorry for the interruption. So remember power of a power rule. You just multiply 4 to each term. Actually, to each variable in this scenario. So that would give us x squared times exponent 4, and another one would be y cubed and 4. If you multiply the both of this, that would give us x to the power of 8 and y to the power of 12. And simple as that, that's your final answer. And another one, last one, before moving on to the power of a quotient rule. And that would be 5a squared and b cubed. So that would be 5 cubed a squared and b cubed. So the rule that applies here, there are multiple rules used there. First is the power of a power rule, and I would say product rule if I'm right, but let's just answer it. So 15 cubed, that would give us 125. Yeah, 125. And a squared and an outer exponent of 3, that would give us 6. And that would give us automatically b cubed. And that's your final answer. And moving on, we're going to talk about power of a quotient rule. So in the power of a quotient rule, you distribute it again. But the difference of power of a product rule and power of a quotient rule, it's a fraction format. So that would be, there would be a numerator and a denominator. And what will happen is there will be an exponent that will be distributed to both the numerator and denominator. So basically like this. And they are distributed to both the numerator and denominator. And n is the exponent. So that would be an over b to the power of n. Yeah. And let's answer some examples. So here we are given x over y squared. Here we just distribute squared to both the numerator and denominator. So that would be x squared and y squared. You cannot simplify it furthermore because they have different bases. And remember the first rule, the power rule, yeah, where you just add it by the same basis. And the quotient rule, where you just subtract it, where you divide it by just the same basis. And yeah, that's all you need to know there. But this is the final answer. So another example would be 2 to the power of 3 cubed. So if I distribute it again, you distribute it again to the numerator and denominator. So that would be 2 cubed over 3 cubed. And that would give us eighth over 27, because the value of 3 times 3 times 3, or 3 cubed, that would be 27. And the value of this, or 2 times 2 times 2, is eighth. And that would give us the value 8 over 27. Another example would be x squared over y to the power 3, and an exponent of 4 in the fraction. If you remember power of a power rule, you distribute it, but you multiply it. So basically, x to the power of, you multiply the fraction, the exponent, and you multiply it as well to the denominator. So that would give us x to the power of 8 over y to the power of 12. And that's your final answer. And another example would be 5a to the power of 2b squared. Let me fix that. But that's fine. 5a over 2b. So you basically just need to distribute it to the denominator and the quotient, numerator and denominator, and also by the quotients and the bases. So since you distribute it to the quotients and the bases, that would give us 25a squared over 4b squared. That's the final answer. And that's all you need to know for power of a quotient. Zero exponent. This is a simple thing that for exponents. If you know about exponents with that has a value of 0 is equal to 1 all the time. So 10 to the power of 0 is equal to 1. Another example would be 21 to the power of 0 is equal to 1. 3y to the power of 0 is equal to 1. That's all you need to know for the zero rule. Zero exponent, sorry. And another example would be 7 squared times 0. Times x to the power of 0. That would be 49 times 1. And that would give us 49 automatically. Because the value of 7 squared, 7 times 7 is equal to 49. And that will give us 49 times 1 is equal to 49. That's how you get the value of that. I'll give three more examples at least. 3ab to the power of 3 times b 0. So given the fact, remember the power of a power rule, power of a power rule, just distribute it to each one of them. So that would give us 9a cubed and b cubed. And remember, if you're given an exponent of 0, that would equal to 1. So times 1. So basically, the final answer would be still 9a cubed and b cubed. That's your final answer there. I think that's all you need to know for zero exponents. So negative exponents. So here we just basically reciprocate or invert the base to the denominator and that will make the exponent positive. So for example, x negative 2. What we will do is we will put it in the denominator and that will be positive. That's all. That's simple as it is for the negative exponent rule. But I will also show how to turn it into a positive using the long method, what I call the long method. But I will just show it later on because I want to make the video as short as much as I can. So moving on, another example for the negative exponent would be 2, 2 and negative 4. So basically that would be just 1 over 2 to the power of 4, and 2 to the power of 4, that would give us 16. The value is 1 over 16. And next would be 3a negative 2. Since we're given a power of a power and a negative exponent, so I would first need to do the negative exponent rule, where I invert the base to make the exponent positive. So that would leave us 3a as a denominator, and if we distribute it by using the power of a power rule, that would give us 1 over 9a squared, and that's your final answer there. And here, also I will provide at least 2 more examples and to end this video. And another example would be to the power of negative 2 and x to the power of negative 3. So following the negative exponent rule, x to the power of negative 2 would go below. So that would leave us x squared and negative 3. But we still have a negative exponent. So what we will do? So what we will do is just we will put it on the numerator. So that would give us y to the power 3 and x squared. And that's your final answer. And last one would be wait, 1 to the power of negative 2. Let me think. 1 to the power of y negative 2. And in order for this to become positive, we just put negative y squared, y to the power of negative 2 to the top, or to the numerator. And that would leave us y squared, because basically if your denominator has a negative exponent, you just move it to the top. And that is the rule for a negative exponent, you just invert it. So basically if the top has a negative exponent, it will go below. So that would give us x over a to the power of b. And another one would be let's say 9a to the power of negative 2 over 1. Or I could say over 3. So in order to solve this problem, this is kind of pretty long, but don't worry, I'll try to show it in a simple way. Let me write it here. 9a to the power of negative 2 over 3. So if I distribute the negative exponent to each of the coefficient and to the base or the variable, that would give us negative, not negative, but rather yes. So that would give us 1 over 81 squared. And remember, we still have 3 here. So you need to divide 3 by result. So that will give us 1 over 81 a squared over 3, but the expanded form, or basically, I'll just rewrite it. 1 over 81 a squared times 1 over 3, that would give us a value of, basically we need to multiply 81 by 3, that would give us 243. So your final answer would be 243 a squared. I wish you learned something here, and if you don't get something, just comment and leave a comment, and I'll fix it as much as I can. Thank you, bye bye.